Thank you. This is another part of trigonometry. We'll be talking about trigonometry. We'll be talking about the trigonometric ratios. Okay. Now, this ratio applies to the right angle triangle. So I'm going to put down right angle triangle. Now, previous video we already established that this is the hypotenuse. Okay. Let's see, we're talking about this angle A. So let's term this as angle A, B, and C. So let's see, we're talking about angle A. Then we already established that the side opposite gives you the opposite, and of course the other side, which is next to the angle, gives you the adjacent. Okay. Now the next is we want to quickly deal with the trigonometric ratios. Now there's an acronym which of course a lot of students are used to, and that is called the SOHCAHTOA. You could put it this way: SOHCAHTOA. Now, this is the acronym for the trigonometric ratios. Now, what does it mean? Let's explain. This ratio deals with the relationship between an angle given and the sides of the right angle triangle. Now, since we already know the three sides, sine of an angle A, which is what we are referring to right now. So sine, that's what the S is, sine of A will give you, is equal to the ratio of the opposite to the hypotenuse. That means opposite over hypotenuse. So that gives you opposite over hypotenuse for short. So sine A is equal to opposite over hypotenuse. So that is what this represents. Okay, so sine A is equal to opposites over hypotenuse. Then the next is cos A. Simple. All these are relationship. Cos A. Cos A on this angle is equal to adjacent. This is the adjacent over hypotenuse. That's the hypotenuse. Then we have tan A. Tan A gives you opposite, which is this, over adjacent, which is this. Sorry, the DJ. Okay, so if you look at this properly, you'll see that, as we said, sine A relates this and this side, the opposite and the hypotenuse. Cos A, on the other hand, relates adjacent and the hypotenuse. While tan A has nothing to do with the hypotenuse, it relates the opposites and their adjacent. So we'll continue and see what of if we have this as B. Now, if you have this as B, if you want to talk about B, sine B, cos B, and tan B, this, for B, this is no longer the adjacent. This will change because we are referring to B. So this becomes the opposite because this is the side opposite B, and also this will change. This will become the adjacent. So, what doesn't change? The hypotenuse. The hypotenuse doesn't change. So, if I talk about B, now sine B is opposite over hypotenuse. You can see the opposite is no longer here, but here for sine B. So, opposite over hypotenuse in the shape. Then cos B is adjacent here over hypotenuse. And finally, tan B is equal to opposites, which is this, over adjacent. Okay, so having known all this, the next is let us insert figures into this and see how they operate. Okay, so let's insert numbers. Okay, so this is 5 and 4 and 3. Okay, so sine B, which is this, gives you opposite. What's the opposite? Opposite for sine B is 4, so that gives us 4 over what's the hypotenuse? 5. The hypotenuse